Hi, everyone. This is Kenneth Wong, editor for DE. Welcome to another episode of DE Webcast. This episode is sponsored by Rescale. Now, before we begin our talk, I want to remind everybody that if you have questions for the panelists or questions about today's topic, you can submit them into the Q&A box at any time. We'll address them in a Q&A session. After our discussion, we'll spend as much time as we'll address as many questions as time permits. You can also download a PDF copy of today's slides and check out the resources related to the topic to the resource list to the left of your window. If you are experiencing technical problems, please visit our webcast help guide by clicking on the question mark icon at the bottom of the console. Now, if the slide doesn't seem to be moving or it looks like they are stuck, you might want to try pressing F5. That usually refresh the browser and solves a lot of the issue. So let's get right to today's topic, shall we? It's not a secret that if you want to speed up your computational fluid dynamics analysis, generally referred to as CFD jobs, you can add on-demand computing. But how easy is it? Can you just go onto a public cloud provider like AWS, rent a few dozen CPUs and GPU cores, and add them to your job processing queue? Today, we'll talk to two people who have first-hand experience working with this kind of workflows, and we'll address your specific questions related to this particular type of setup. So let's meet our panelists. The first one we have is Sudip. Sudip is from Daikin Applied, America. Sudip, welcome. Would you mind just doing a brief self-introduction? Tell us who you are and what you do at your company.
Yeah, hi, hello everybody, good afternoon. My name is Sudip Mukerji, and I'm from Daikin Applied Americas, and I function as an CFD subject matter expert, mostly supporting product development and evaluating new technologies.
Very good, thank you very much. We'll come back to you and ask you about the specific jobs and the challenges that you have. So we also have Clinton, but Clinton seems to have dropped up a little bit from the camera right now. So maybe he's just signing back on. So, all right. Hi, Clinton. Welcome back. Clinton, would you mind also doing the same thing? Introduce yourself. Tell us who you are and what you do at Rescale, please.
Yes, my name is Clinton Smith, one of the solutions architects at Rescale, and my job is to help customers take their CAE simulations to the cloud. My background is in CFD thermal for quite a while, and now I get to help customers realize those goals, running those types of calculations on cloud computing.
Very good. So we'll start off by talking to Sudip about his experience. But Clinton, my understanding is after that you will actually do a screen share and give us a demo of how to set up a CFD job in the cloud. Is that right?
Yes, absolutely.
Very good. We look forward to that. So Sudip, let me start with you. Sudip, would you tell us about the kind of simulation that you have to do at your job? What's a product, and what are you trying to figure out about the product when you do CFD?
Yes, thanks, Kenneth. I'll just give you a few sentences about my company. I'm from Daikin Applied Americas. It is a subsidiary of Daikin Industries Limited of Japan. We are the largest HVAC manufacturer in the world. Our revenues in well over $20 billion, and we employ over 67,000 people all over the world. We have 90 different manufacturing locations, and we sell our products in 150 countries. We make large HVAC devices in the premium commercial market, which include, large package rooftop systems, chillers, water source heat pumps, and modular control central plants, and many others. So on the simulation front, we do fluid flow, CFD, finite element method for structural work, and we also do system-level simulations. And most of the work that we do is in support of new product development, to iterate on designs, understand the weak point of designs, understand the sensitivity of the designs to different inputs and stuff like that. And then we also work towards integrating new technologies into our products. So right now, the thing that we are excited about is a new refrigerant called R32. This has a lot of promise because it has about 1/3 the global warming potential of the current existing refrigerant, which is R410A. And our testing also shows that we can improve efficiencies by 12% when we use this refrigerant. And this refrigerant is thermodynamically very efficient, so we require less amount of it. So only 40% of the charge will allow us to move the same amount of heat as the current refrigerant. So that means smaller compressors, smaller diameter piping, smaller sized heat exchangers, smaller diameter fans. So, less weight, smaller units. That means we have to, ship things that are much lighter. So overall, all around, it's a very green story. But it also means that we have to do a lot of HPC computing work to resize and redesign our products to handle this new refrigerant. In addition to new technologies and new product development, we also do one-off troubleshooting issues. So with the growth of cloud computing and cloud, everything moving to the cloud, there is a lot of large explosion of data centers. And these data centers give off a lot of heat. And so our chillers business is a growing part of our business. We use chillers to cool down these data centers. Now, a single chiller is a large unit. It might be like 30 feet long, 10 feet in height, 9 feet in width. But a single chiller is not enough to cool data centers. We have to use what are called chiller farms, where we put like 30, 40, 50 chillers on a roof of a building or on a separate, concentrated plot of land to cool these data centers. Now, these chillers are giving off heat from the condenser coils. So a single chiller in isolation is okay, but when you are packing these chillers in together like that, and there is a chance that the heat given off by one can actually be entrained into the coils of the another one. So there is this interference effect which reduces the efficiency of the chillers overall. And a problem of this size and magnitude can only be done on HPC clusters. There is no other way to address this. So this is some of the work that we do.
I was going to ask you why you needed HPC, but you have addressed that. But maybe you can also give us a comparison. If you do the kind of thing that you need to do on a typical workstation, even a top-end workstation with a quad-core CPU and maybe a couple of powerful GPUs, can you practically do it, or would you actually need to do HPC? And could you also maybe talk about how easy or how difficult it is to add HPC to a current setup? So you may have your own server, and you're also getting some cores from the HPC. Is it fairly easy to mix the two? What's your experience?
The way this thing works at Rescale is that it's fairly simple interface. It's a web-based interface, but we do not mix our own servers and Rescale. So it's basically we compute on Rescale, and we set up our clusters and the hardware architecture on the fly and compute there. And so, yeah, it's relatively easy to do that. And you know, like speed-wise, like some of the problems that we are doing right now, yeah, some of them could be done maybe on a quad-core machine, but only a few of those could be done. We are exploring the entire design space, so hundreds of points to understand the design and its sensitivity. So it would take like months to do it on a smaller machine. And some of the examples that I talked to you about, like the chiller farm and some of the other examples that we are doing, simply could not be done on the machines, on a smaller machine.
Is it fairly easy to do the setup? By that I mean, could somebody imagine that they could just go on Amazon Web Services and buy some cores and put it into the queue as processing? Or is there something about the Rescale setup that makes it easier for you to, say, couple those cores with the CFD software that you already have, you plan to run?
Yeah, so it's a pretty simple thing, I would say. It's a web-based interface, and it's simple enough that we are rolling it out to our junior engineers now, so they are also kind of productive using HPC. And so you transfer your files to Rescale and you compute on the cloud there, and then you transfer your results back. That is the way it works. And we tap into our own licenses that we paid for, and we can have Rescale tap into those licenses. We built a specialized secure tunnel to do that. And then, you know, like, in the experience that I have, you know, Rescale provided us a generous amount of time to do a proper proof of concept evaluation of how our problem would work on Rescale. Then their Rescale support engineers were also willing to work with us to address our pain points. And we had suggestions that would improve our workflows and processes, and some of them have been, you know, implemented on the website by Rescale. So yeah, it's an evolving thing, and they do make it quite easy to work on it.
All right, very good. The audience is already starting to type in questions. I can already see some of the questions. So we have some time before we go to Clinton. So one question to Sudip, maybe you can actually help answer. Somebody wants to know, is it fairly easy to upload a large file that you need to run CFD on, maybe a large mesh file, into the cloud so that you can set it up and run it in the cloud? What's your experience with that?
Yeah, so larger the file, obviously more time it will take. But you know, like if you are really doing a true HPC thing with literally 50, 60 design iterations, or a problem size that is like 10x or 100x of what you can do currently, then the file transfer to Rescale and the result download from Rescale kind of, it's an overhead, all right, but it kind of goes away. I mean, if your job gets done in 15, 20 minutes at Rescale, then probably it is not worth the hassle. But I'm talking about really large HPC jobs.
Very good. Understandable. Okay, Sudip, thank you very much. We hope you'll stick around and help address some of the questions that the people will be sending us in. So the audience, you can type in questions at any time. Now we go to Clinton. Clinton, you are going to give us actually a an explanation of the process itself and also talk to us, give us a demo on how to run this process. So go ahead.
Yes, absolutely. Thanks. So I wanted to start with looking at some of the challenges and pain points that we hear from our customers, and Sudip touched on a few of these already. These are common. Speak to how that we can address those with Rescaling platform. So one of the big ones that we hear often from customers is that they have to wait in queues, and queue time can be on the order of minutes, it can be on the order of hours, or even the order of days or longer, and that slows down the design review process, the product development process. Another one is the ability to scale, and that is mostly due to fixed size resources, whether that's workstations or whether it's on-premise HPC. There's a fixed size to that, and that often limits what the engineers and the scientists are able to do as far as getting the results faster or running more cases and populating, say, a parametric space. Another common pain point we hear is an inflexible architecture. So essentially, having one sort of monolithic or homogeneous infrastructure that is set up for running all types of workflows, whether that's CFD or finite element analysis or electromagnetics analysis. We do hear that from time to time as well, and try to find ways to address it. And then the last one is, of course, reliability. There is end of life with on-premise hardware, as everyone is well aware. And toward end of life, reliability comes into play as a potential issue. And the question becomes, how can engineers and scientists really think about improving R&D, and even to the point of, can we supercharge it? Can we get it to a point where we can digitize the product development process and start to realize the promise of a digital twin? Similar to the picture there with the turbofan engine, where on the lower right we have the CAD detailed design. Then we're trying to move toward a digital simulation design, and then ultimately to the hardware, the actual prototype built for test. And what Rescale and intelligent computing enables is the ability to explore more design ideas and measure the physics, and ultimately not to eliminate tests, but to reduce the amount of tests and the amount of built prototype cost, which is very, very high in many cases. And I also wanted to cover the question of a digital twin. Why is that more realistic? Why are we toward that end now, even more than, say, 5 years back in time or longer? I would submit that one possibility is that a digital twin really requires a population of the parametric space for that device, not just a few variations here or boundary conditions there, but the ability to populate all of the multivariable space for a component as well as for multiple components, and even out to the entire system, and then to explore that space. That's the hard work of making a digital twin, is generating that data set. And I think that we're at a point now with access to
Clinton's audio seems a little bit. Clinton, would you mind repeating a little bit of what you just said? Clinton, would you mind repeating a little bit of what you just said, because your audio seems
in the cloud.
I apologize, audience. I think one of the panelists, Clinton, seems to be having some connection issues. Let me go ahead and send him a message and get him back on. In the meantime, Sudip, if you're still with us, let me chat with you a little bit, Sudip. In terms of what you are doing here, typically when you're exploring design of experiment or trying to figure out what you want to do, are you verifying various variations of designs? I mean, dozens of designs at the same time, or are you verifying just one or two at a time? What's your typical setup?
Is the audio back?
All right.
So whatever you're doing in an existing sense, like you can do many more of those with an HPC. So yeah, you can set up a parametric design space for exploration, try out different flow, operating condition, or geometry conditions, many more of those. And also the other part of it is you can tackle really large problems that you cannot do currently. So those are the two that we are looking at. Yeah, so and also this is down in the future, we would also be, doing, which we don't do enough of right now, is optimization, design optimization. Let the design loose with an optimizer, which builds the response surface as it solves, and then, lands on an optimum value within some specified constraints.
Okay,
that is
very good.
Yeah.
Clinton, are you back with us? Can you hear us? Hey, Clinton.
Yes.
Welcome back.
Can you guys hear me okay?
Yes, we can hear you okay now. So this is exactly where you left off. We were just chit-chatting a little bit about design of experiment with Sudip. So I'm going to hand it back over to you. Continue from there, please.
Yes. Apologize for the issues here on my side.
No problem.
Just two more slides here before we jump into the demo. I'll just cover the left-hand side of the slide, the business and IT. Value proposition is there for you to read as well, but in the interest of time, I wanted to address the benefits to an R&D organization. And those are
Clinton, I think we still have some audio issues with you. So, Clinton, maybe you can actually dial in from the phone line and then continue the presentations. But in the meantime, I'm going to go ahead and chat with Sudip. Sudip, in the type of simulation that you run, does it make a difference if you run it on a CPU or a GPU? What do you find is more beneficiary to what you need to run?
That entirely depends on the type of problem and the type of software. So for the most part, I would say flow simulation using CFD may not benefit a whole lot from use of GPUs. But I think there are certain finite element FEA cases that do benefit from using GPU thing. So whatever we do is mostly using CPU. And there is, there is a benefit that Clinton was talking about. This was not something in our evaluation criteria when we were looking for a cloud services provider. But we found that FEA actually works better on certain core types, and CFD on a different core type works better. And even within CFD computation, there may be cases that benefit from like a high InfiniBand interconnect kind of thing, where there is other class of problems that benefit from higher clock speed and more memory. So when you have an in-house cluster, there is no way to tune the architecture to this. But that is a big thing that Rescale offers, that you can set up the architecture and tune the architecture on the fly at the time of computation. So that's a big thing, yeah.
Thank you very much. We'll come back and have you address more questions. So right now, I think we've got Clinton back on the phone line. So we're going to try to see if just Clinton can do it on the audio without going on the webcam, because for some reason the webcam operation seems to be interfering with his demo. So Clinton, if you're back with us, I'm going to hand the presentation back over to you. We can see a slide and you can keep advancing and keep talking to us.
Great. You guys hear me okay now?
We can hear you okay. And if you have control of the presentation, keep going from these key businesses and IT benefits. And if you need help, I'll advance the slides for you.
Great, thank you. Yeah, let's go ahead and jump to the next slide.
Okay.
This is the last one I wanted to cover before going into the demo.
Okay.
This is a case study from Nissan Motor. There's some really amazing metrics that they were able to realize in their journey from on-premise to running simulations in the cloud. There's the statement there from the GM of Nissan standing there in the picture. And I'll draw your attention to the bottom row of the slide with those metrics. From an expenses point of view, looking at total spend from on-premise to using cloud, there's a 52% reduction in those expenses. So that's pretty incredible as far as savings. From an efficiency point of view, with respect to the queue time, on average, the engineers were realizing 2 to 3 days of queue time per job. And that's been reduced 99% by moving to flexible computing with Rescale. And then the last but not the least there, under applications and productivity, the ability to abstract away the management of software applications and sort of the platform managing all of the simulation metadata resulted in an 18% cost optimization. So a pretty nice metric there as well. With that, I think we'll move ahead to the demo.
Very good.
Make sure the screen share is working here.
Let's see if Clinton can share his screen and run the demo for us. So Clinton, we're still waiting for the demo to come up.
Okay, let me know if you're able to see it now.
Yes, we can see the screen now. To the audience, you might need to maximize the window where you are now looking at the demo. And after that, you can minimize it again so that you can follow the slides again. So, Clinton, we're ready. Go ahead and do your demo, please.
Great. Thanks, Kenneth.
Yep.
So I have a few things I'd like to show you today with respect to the experience on the Rescale platform. The first one is a batch-based workflow with Fluent. So let's take a look at that. Everything you'll see me do here on the platform has the ability to be scripted as well with APIs. And the workflow, we've really spent some time thinking about how do we make this process as simple as possible for the end user. So there's really optionally four things that are required to run your job on Rescale. And in our case, we're going to bring in our case and data files, and then we'll bring in our journal file. These have been uploaded already to the cloud, as Sudip mentioned. They can also be brought in from on-premise. So that's this middle option here. So we have our input files. We also require the software and then the hardware that you're going to run on. You can jump between these steps at any time in the workflow. We'll take a look at software. I'll select Fluent. And then we have the ability to select multiple versions. Those are maintained for you by Rescale. And then we have our input files listed out for us. and our run command for Fluent. The only thing we have to supply here is the journal file name. We can do that with a click, and Fluent is ready to run now across as many cores as we require for the simulation. The last piece here with the batch workflow is setting up the licensing. And what we find, as is the case with Daikin Applied and Sudip's team, you can use an existing owned license that you can bring to use on Rescale. How does that look like? It's quite frankly just the reference of a port number and the license server name. And once you have that specified, it's actually saved in your environment, so you don't have to remember it. I'll just type it in to show that in this case. You are ready to select your hardware. The last piece here is really my favorite part of the Fluent and Rescale platform experience, because you have the ability to see that there's various types of hardware available, quantified by different unique features, whether it's the interconnect or the memory or the clock speed. And you have the ability to compare and contrast those as well using this tool called the Core Type Explorer. So let's save our job before we move here. Core Type Explorer is a nice feature built into the platform that allows you to compare some of these different cores by various features. So we'll add one here for bandwidth. For CFD, we definitely need a high bandwidth network for all of those MPI communications between all the partitions of the model. And we can sort of add or remove processors here until we are happy with sort of the down selected list. And then we can mouse over and sort of compare them by those, whether it's cores per node or memory per node. I actually prefer the radar chart view myself because as you sort of select one corner of the chart, you have a table that ranks everything for you. And so with network bandwidth, we get a list here and find, that we definitely need 100 gigabit, the InfiniBand capability for a CFD run. And in our case, we're going to select Carbon. We could easily select as well Amber V2 or some of these other ones. So let's jump back to our job. There we go. And at this point, we'll select Carbon, and we can dial this up as high as we need to essentially deliver those results in a reasonable amount of time, or even faster than we could before. Again, assuming the licenses are there, assuming the model scales that high, we can dial that up because the resources exist, and we can scale up and get those answers much more quickly than ever before. Now, for my small demo problem here, we don't need 600 cores. We can live with 44. And at this point, we are ready to submit our job. Now, I've already submitted this job, so just in the interest of time, I want to show you what the job actually looks like while it runs. So here is the same job. Been running for a couple of hours today. And there's a few steps that happen before the job begins to run. There's the validating input, which is just a sanity check. There's this of the specifications from the licensing and the input syntax. There's the startup of the cluster, which is basically going out to the cloud resources, requesting them and standing up for the environment. And then there's the running of the job itself. And when the job runs, there's some nice features that are available for you to monitor the progress. This first one here is called live tailing. This is a list of all the files that are being created by this simulation. Some of them are picture files, others of them are log files. The top level Fluent output is placed into a file called process_output.log, and this is live updated as the simulation progresses. You can use this live tailing feature to review multiple different types of files as well. With that, that is what I wanted to show you with the batch workflow as far as a Fluent batch process on Rescale. We can also do these same things with Ansys Mechanical, with Workbench as well, can be run in this context. What I'd like to do now is come back and show you an alternative workflow for Fluent again. And in this case, we have the requirements for an interactive environment where the Fluent UI is available the entire time. And that type of workflow on Rescale is called an end-to-end desktop. The first step here is just to select that workflow from the job type. There's a message here that Rescale gives you. It's basically just letting you know what end-to-end desktop is. It is a Linux desktop sitting on top of a batch cluster of arbitrary size. So however many cores you require, you do have a desktop that sits on top of it and provides you the ability to run that calculation with the UI available the entire time. We'll select yes. And then our workflow diagram looks very much the same as a batch workflow. So we would bring in our files from cloud storage. We'll select our software. In this case, we'll select the Ansys Interactive. And then similarly, we would specify our license as we've done before. And then we would select our hardware just as we would for a batch job. So very, very similar, but the effect of it once we submit the job is a bit different, and that's where I'd like to spend a few more minutes on that as well. So we could click on Submit. Spin-up time is on the order of 5 to 7 minutes. And let's take a look at this job that's already running as well, because I want to show you what it looks and feels like once it's ready to connect and run the UI-based simulation workflow. Once end-to-end is available, this button Connect will light up, and once we select that, we get another browser tab that opens with the window technology going into that running desktop with all of our software applications and our files available for use. And there's our different Ansys applications listed out there, whether it's Fluent, Workbench, Electronics Desktop, FenSAP, CFX. They're all installed and available. We're going to use Fluent. So we quite literally can just double-click, set the number of processors, our case and data files, as well as our licensing capability, and we're ready to go. Now, again, in the interest of time, I've already started Fluent up for us with this same model. And so let's take a look at just the interactive nature here. If we were to run Fluent for, say, a couple more iterations than maybe what we've done, what would that look like? And then I also want to just show you what this model looks like as well, because I think it's a useful, simple case that's similar to the things that Sudip and his team are doing. That's an internal flow with heat transfer. So we have a heating coil there in that annulus, and then we have the cold flow flowing from left to right across the picture to cool off those tubes. If we go ahead and calculate, and we have our Fluent UI available, we can watch the residuals convergence. We can do live updated contour plots. So we have the ability to interact with Fluent just as though we were sitting directly in front of it. That brings me to the end of the user experience demos. There's one last thing I wanted to cover before we wrap up the demo.
All right.
Let me come out of that view. This is a really nice feature that I'm really excited about at Rescale. We've created this. Let me minimize everything else so we can see what we're doing here. Apologies. Here we go. We've created this feature called the Performance Dashboard. Why is this useful? Because what you can do, in this case, we have an LS-DYNA workload shown here. We have the ability to look at what is the spend according to that workload over some time period. So we get an average representation of the job duration, the job cost, the license type, and then if there's a better way to, or more performant infrastructure to run that workload, Rescale will let us know that, and it'll make this little optimize button available over here on the right. So we click that. Make this a little larger so we can see. When we click on optimize, what Rescale does is it does a statistical analysis over that time period, looking at how we run, in this case, LS-DYNA, across multiple different hardware types or infrastructure. What's our average core hours used? What's our average job duration? And then what's the best case scenario from a core that we should be running for that workload. And oftentimes there'll be a list available and there may be one core type that gives you the absolute raw performance fastest result. There may be another one that gives you the most cost performant or cheapest result. Sometimes they're the same thing. And so here, for this example, Carbon turns out to be both the fastest and the cheapest for this particular set of LS Dyna workloads. So I just wanted to present that briefly there. I'm pretty excited about this feature, and our customers are as well. I know Sudip and his team are starting to use it. I think it's really, really useful from an engineering point of view to be able to say, here's the best case scenario for me and what I'm trying to accomplish. So with that, I will pause, stop sharing for a moment, and back to you, Kenneth.
All right. So I think you still have a couple of slides, right? A couple of wrap-up things you want to talk about. So if you're ready for that, we'll go back to the presentation, and go ahead, Clinton.
Yes. Thank you. So just to wrap up, as far as what Rescale represents, an intelligent computing platform for digital research and development. And we see below the line there, what does that look like? Well, it's HPC, it's automation of the cloud process, it's all the operations around research and development, and then of course the business management side, which we just touched on very briefly with that performance dashboard. I'm going to skip 2 slides ahead, Kenneth, if that's okay, and then I'll come back to the example slide here. This is just a representative case I included here for one of the demos that I showed you. It was an internal exhaust flow, and we did look at a comparison between hardware types and performance. In this case, we're quantifying iterations per day, so you can think of this like a speed up graph, faster on more cores from left to right. And the colors represent different types of hardware. So similar to, as we were looking at the core type explorer for a few moments, you'll see some of these names available, and there'll be different characteristics or features, right, of these different pieces of hardware. So that's what this graph represents for this case. And as we kind of go from left to right, we're looking at nice linear trends, both from Carbon, the blue line, as well as Amber V2, the green line. The Serpentine, the yellow line, follows speed up pretty well, but the red line has a little bit of drop off as we go higher in core count. And so these are the types of things that are possible to the questions you can ask using Rescale because you have access to these types of hardware, and the questions that our team can help you address as well as part of the platform experience. Now let me come back to this slide here. I'll leave this one up here so that we can make available the fact that you can sign up for a free trial of Rescale. There's the link right there. I think it's in the webinar information as well, if I'm not mistaken. So please feel free to take advantage of that, and you can do there we go. We can do a trial of Rescale with your software or with other types, other workloads that you may have as well. And again, feel free to reach out from our website with any questions that you have. So with that, I'll hand it back to you, Kenneth.
Very good. Thank you very much, Clinton. Good demonstration. Okay, audience, now we are going to start addressing your questions. So we already have some questions. We're going to start with that. And while we're doing that, if you have more questions, feel free to type them in. Let's start with this question. What's a good way to determine the right HPC setup for my CFD job? So I'm going to start with you, Clinton, and then maybe based on his experience, Sudip will also add some thoughts to it. So Clinton, could you start us off with that? What's a good way to determine the right HPC setup?
Yes. Well, I think there's a few things that go into that question. One is, of course, the underlying infrastructure. So we talked a little bit about that with the demo, showing the core type explorer. So there's sort of a features ranking, if you will, between the infrastructure type. And then the other part of how do I select the hardware is a benchmarking type of exercise, similar to what I showed a few moments ago with that one slide. But there's more to it as well. I think there's bigger questions around the workflow itself, and that's something we typically would sit down, with you and your team and say, how's your workflow look today, and then how would that look in a cloud computing intelligent platform type of environment like Rescale. And it can vary quite a bit. But questions such as maybe there's pieces that one pre-processing flows into the solve that flows into the post-processing. Those types of questions, some of them are built in to the platform, but others of them we may need to work with you to build in as well.
All right. Sudip, do you have anything to add? When you were picking the HPC setup that you need to do, well, what are the characteristics that make you go, this is the amount of core I need, this is the type of setup that I need? How do you decide?
A little bit of my own experimentation and mostly consulting with Clinton and others at Rescale. That's how it works, yeah. And that core type Explorer tool that Clinton showed, going forward, that would be a big help too. If we have something totally new that we are simulating, to figure out where we could get good efficiency for our computation.
All right. This one is for you, Sudip. And while Sudip is answering this, Clinton, would you also do us a favor and take a look at some of the audience questions that we have received? And if you can help us prioritize them so we could queue them in the order in which you would like to answer them when we come back. So, Sudip, the question that is directed to you is, do I have to learn a lot of new stuff to run HPC in the cloud as opposed to as opposed to running CFD on premise? What's your experience say to that?
Yeah, that was definitely one of our criteria, and we did not want to learn a lot of new stuff to just run HPC in the cloud. And a web-based interface like Rescale offers is a good option. You just need to figure out how to navigate around their website. And it is simple enough that, we are rolling it out to our junior engineers who are using HPC and being productive. So, yeah, that's my answer.
All right, very good. Let's take a look at another question. So this one says, do you see the dollar sign, in other words, the cost, what it's going to cost you before you hit run? That's a good question. It's a big concern for many of the companies. You don't want to be stuck with a huge HPC bill after you run the job. So, Clinton, you want to start us off with that? Clarify how this works in Rescale setup.
Yeah, so when you set the job up, there is, you may have noticed briefly in the demo, there is a quantification of the cost per hour based upon the hardware resource you've asked for and how many cores you've asked for from that resource. That's an estimate. The total job cost can be estimated by looking at like a benchmarking type of exercise where we say we think it's going to run 2 hours, 4 hours, 15 minutes, and then multiply that by the rate, by the hourly rate. So that's one approach. There's many more that could go into that, but that's kind of a kind of user-based view. So there's technology built in, like I showed you just briefly there with the performance dashboard, where we're building that intelligence into the platform as well, so that those questions can be answered in a more formal way by engineering management, by IT or business management as well.
Okay, very good. Another question that we have got here is, my experience has shown that HPC in the cloud is could be significantly more expensive than on-premise. So I guess that's a value proposition question. I'm going to have you address that first, Clinton, and then I'll come back and ask Sudip also to talk about that based on his experience. How does the two cost structures work? So, Clinton, go ahead.
Sure. I think it's important when you compare these things to look at the full picture. So that's something we really strive to do looking at what's everything involved with the on-premise cost, not only just the cost of the hardware itself, but the surrounding infrastructure around it, the power coming to it, the building costs, the HVAC, and the services and people costs, really, of the team that manages that system. So we really try to take a holistic approach, and then we compare that to what's possible with cloud computing via Rescale. And one thing that, from a Rescale point of view, that we also take a look at is not only the bottom line savings or cost comparison, but also like you mentioned, Kenneth, the top line revenue increase contribution. So not only what are my costs, but what type of additional revenues or sort of green field opportunity is there by moving to the cloud. And again, that's something we've done with Sudip and his team, and we always do with our customers.
Sudip, your experience on-premise cloud on-premise running CFD on-premise cost versus in the cloud. So how do you justify the two when you pick one or the other?
Yeah, I do not have any numbers that I can share with you right now, but what I can say is this cloud computing is evolving very rapidly. Even if you did this evaluation like a year or a year and a half ago, things might have changed from that time now. That is one. And then, when we decided to go to Rescale, we did have an in-house cluster. And that was, not very reliable. There would be nodes that failed from time to time. So to minimize the impact on our jobs, we would kind of compute with fewer nodes as possible so that our job did not fail. And also, because of restrictions of operating systems and OS software and other software that were on the cluster, we were like at least 2-3 versions behind on the say the CFD licenses that we were there, because we could not load a new version without upsetting everything else. So that made things efficient for the people that wanted to use the latest and the greatest new license. So so there is a lot of intangible cost associated with the in-house on-premise cluster too.
Very good point. If you have to strip down your simulation to a much simpler, lower fidelity just to be able to run on your on-premise setup, then there's an unseen compromise that you're making, even though it looks like you're saving money. I think there is one last question. It may be a good question for us to end on, and because we're about to hit the 1 hour mark. So this question has to do with digital twins, since Clinton, you brought it up. Do I have a way to link the digital twin in Rescale with IoT devices, sensors that are in the field, whatever, and actually run a realistic representation of what the real thing in the field is doing? So, Clinton, could you maybe start talking about that?
Certainly. Yes, I think in general, yes, it is possible to do this. We've collaborated with some customers in the past to look at how can a large sensor data set be made available in a cloud environment. So there's always some questions around what's the most efficient way to do that, how's the data being queried, and so on. So we do provide the ability to interface with additional cloud services, right, like a data lake type of architecture, where you may have that data set sitting there and you're querying it live in a feedback loop. So I think, yes, it's possible, and that's where things will trend, have been trending, and will continue to trend, that we're seeing in the field.
All right, very good here. So, Clinton, how about your thoughts on the issue? Do you have a digital twin of some of your products? Have you ever attempted connecting them with IoT sensors to see how it would work?
I personally have not. We have customers who are considering this. Some of them even doing it now. on their own presently, and then I think we'll see more of it in the coming months and years. But I personally have not helped the customer set it up yet.
Very good. Sorry, Clinton. I meant to call on Sudip, since Sudip is actually in product development. So Sudip, would you maybe talk about your experience with digital twins?
So yes, so we are in the process of building digital twins. We are investing both in personnel and software. And in our understanding, digital twin would be, like a systems model with all the subsystems like fans, heat exchangers, even at the fin level maybe, and the whole refrigeration cycle, airflow, all those we would be using HPC's CFD simulation to build the database on which the digital twin will be built. So that is next steps for us. So we anticipate using HPC heavily to build the database on which the digital twin will work.
Very good. All right, let's wrap up, gentlemen. So I'm going to start with you, Clinton. Give us maybe about 1 minute of your closing remarks, your closing thoughts.
Certainly, Kenneth. I did see a question as well. I just wanted to touch on briefly in my 1 minute wrap, and it was regarding the spot pricing or dedicated pricing question with respect to cloud computing resources.
Sure.
And the short answer is we support both at Rescale, and we can certainly follow up with you with details. But one of the great value propositions is that we support the spot market without and alleviate a lot of the risk associated with the spot kill. And I can explain more details, offline, but I just want to cover that briefly. I'll wrap by saying a great thank you to the team at Daikin Applied and Sudip and his team of engineers. We really enjoyed working together. Thanks for the opportunity, Kenneth, Steve, and the DE team. We're really happy to have this opportunity to talk about the intelligent computing platform that we have at Rescale that we're super excited about.
Very good. Thank you very much. Sudip, closing thoughts, closing remarks?
Yeah, so for us, we look forward to using a lot of HPC going forward. I had mentioned design optimization, that actually using an optimizer to optimize the design, and then building of digital twins in the future. Then I had mentioned transition to R32, which is a low global warming potential refrigerant, but that requires the transition of our entire product line for the redesign of that. And then further, the other thing that we could do is innovation driven by simulation. I had done a little bit of this in my previous job, where you start with blue sky ideas that, okay, you have this current fan, build a new air mover, which is 50 times more efficient. So things like that, or increase the heat transfer through this heat exchanger by X%. So those kind of open blue sky ideas is also down the line. And I would like to thank Clinton for all his support at Rescale, and also you, Kenneth, for having me here.
My pleasure. Actually, I would thank Rescale for making this live event possible, and the two of you for willing to share your insights with us. Technology is sometimes unpredictable. Live events are unpredictable, but we managed to pull together an interesting talk with a lot of new ideas and practical tips to share. So I hope this has been a useful webcast episode for you, audience, and I hope you can join us again. And I also like to thank Steve Paul, our webcast producer who works behind the scene to make everything go smoothly. Until next time, ladies and gentlemen, this is Kenneth Wong for DE, and we are out.